Welcome to the latest edition of Astraveo's Coast-to-Coast podcast of science, astronomy, and the world around us. My name is Joseph, he's David, and we're just two friends who happen to be professional astronomers with a deep love of telescopes, astrophysics, and all things science. We've got a great show for you guys today. Today, we'll be talking about the Great North American Great Solar Great Eclipse, which will be occurring in April. We'll be telling you all about solar eclipses and where and when and how to view them. So, David, you want to get us started? Super exciting event coming up.
It is super exciting, but I'm not sure I've recovered from your terrible joke a few minutes ago. I'm still shocked. Yes, it is a super exciting one. This is going to be my third solar eclipse. The first one was in France about 25 years ago, and it was blinking cloudy. I was very upset. Second one was in Oregon about 2017, I think. That was really good. Before we get going, very important fact: you should never ever look at the sun or solar eclipse unaided. That means without eye protection. Very, very important, especially through optics. So if you have binoculars or telescopes or even your phone, very, very dangerous. So let's not do that.
Look at solar eclipse through telescope.
Do
Got it. Do not look at. Okay, did you guys get that? Because I do not look at solar eclipse. Okay,
do not.
Good.
Yeah, very important. You can all seriously damage your eyes really quickly. So this is a special event for me, actually, for my family, because it's occurring on the 8th of April, 2024, the Great Northern American Eclipse. You're quite right. It's on Tennessee's 11th birthday.
Oh my God!
I know.
So I forgot, when did Tennessee become a state? I didn't realize it was so recent. Only 11 years ago.
That is just awful. I'm not sure. I bet you it must be a long time ago. I'm gonna look that up. Tennessee. It turns out I can't spell Tennessee, which you think I'd have figured out by now. State.
June 1st, 1796. It was the first created from a federal territory.
Oh, look at that, south of the Ohio River. You're right. So it is a really old state, 228 years old. Holy cow.
Yes. Now, you are not a federal territory, so Tennessee, your son, was technically not created from a. Now, and we say Tennessee the sun, we mean your child, not the sun creating the solar eclipse that we're talking about. I feel like we should define our terms here.
Okay, no, that is the sun, not my son. Well,
he's I thought you do kind of own the sun. You just
I wish. I like a copyrighted, like anyone getting sunlight, you owe me $1.
Exactly. Oh, that's a business idea.
I know,
guys. We're suspending Astraveo for the foreseeable future to pursue a dazzling new crypto adventure, Suncoin.
Cure the social climate change is to turn the sun off.
Exactly. But so yes, so the 11th birthday of Tennessee, your extremely adorable, super smart, very wonderful son
is on the 8th of April. Yeah, so
that's amazing. Happy birthday, early birthday to Tennessee. I did not know his birthday was on April 8th.
Yeah, this year.
Doesn't he have a twin? Are they not twins?
Well, they're sort of twins in the sense they're born 2 years apart, but no, they're not twins.
No.
But Morris,
for some reason, they look the same age.
But Morris is a big boy. Yeah, I suppose that could be it. Yeah.
Maybe the last time I saw them, they looked so close in age.
Yeah, I think I just shaved their heads. I'd give them a buzz cut for summer, and they probably.
That was when I had seen them, and I could have. They look. I literally can't tell them apart sometimes. But I suspect I will be able to now that they're a bit bigger. Because I mean, last time I saw them, they were like 8 years old, like probably younger, like maybe 7. If you're under 8, I can't tell the age.
Well, if the baby's about this long, it's a baby. That's not a 7-year-old kid, but yeah. Anyway, you can tell you haven't had children yet, Joseph.
What I mean, what do you get an 8-year-old kid? Like a car?
Right. All right, let's do some
solar eclipses. Yeah,
solar eclipses. So this is an interesting one. We have totality, which is really nice.
Yeah.
And it's special because we won't have totality again for quite a long time. The next time we'll have a solar eclipse, a total solar eclipse in North America, will actually be in 2033, but only North Alaska will be getting the full totality. So we will not here in the contiguous United States anyway. The next one will be in 2044. And then even then, it will only be Western Canada, Montana, and North Dakota that get totality. So this
That's
is
so far away,
it's a
which makes
long.
it extra important that if you can, you guys go and see this
Yeah,
one.
that's right. That's right. So how about why don't we first talk about maybe how the eclipse is formed? If it's a solar eclipse, something has to be blocking out the sunlight, and the something has to be dun,
The
dun, dun,
moon.
the moon. That's right.
Yeah,
So the
so
solar.
David blocks out me background
I,
wise.
okay, there you go. So I'm
Yes.
stopping it now. I'm the eclipse today.
Yes,
So yes,
we call it a is there a word that rhymes with block that I can use to make this joke? It's a
block.
block. Like you're blocking the moon is
You're blocking the moon because the sun is darkened.
yeah, that's
I
the
don't
most
know. I don't know
professional way
where
to
it
put
docks.
that.
Right. We could do astro rap later. How's that?
Yeah, I like it. There you go. Yeah, yeah.
Probably best. This could be
I
really
should
bad as
suppress
well.
my inner Eminem.
Yeah, you probably should. Yeah. Yeah. So it's a solar eclipse, which means the moon gets in between the Earth and the sun directly. So essentially, an eclipse, you're seeing the Earth's shadow projected onto the Earth's surface. You can get different types of eclipse, of course. You can get partial, annular. Partial is just where some of the moon shadow, the disk of the sun is covered by the moon. Sorry. Annular, it means the moon is slightly a bit farther away than usual in its orbit, and so it doesn't quite entirely cover the sun's disk. So you get this sort of annular, so ring of light around the sun. And then you get a total eclipse is when all the conditions are just right. The position of the moon in its orbit, the Earth's concomitant position, I suppose, relative to the sun, and the entire sun appears blocked out by the moon. It's very exciting.
Now, this is kind of confusing to keep track of. So we actually have a really helpful diagram from
Yeah.
NASA that explains it.
Hmm.
Um, so you were talking about the partial solar eclipse is going to occur in this penumbra region, which is the
Yes.
lighter shadow outside, or the not lighter shadow, but the region that's not fully blocked. Now, why is the lighter shadow, the partial region, so much larger than the total eclipse, the total region?
Well, it's because just you get rays from different parts of the sun sort of being scattered and projected as well. Uh, yeah, it's a cone effect. You can see here the light blue cone. The moon actually projects a much larger shadow on the Earth, but the totality when conditions are just right for the shape of the moon's disk to cover the surface of the Earth, the sun's disk, that ends up being a very small part of the Earth's surface. But of
I actually
course,
don't know if this is to, I don't think this is to scale. I think the
well, no,
total, yeah, I think the total umbra and penumbra is actually about the size of the what's drawn here.
no, I don't think that's true. Actually, the umbra is very small. So
The umbra
typically
is
it
very
can be
small, but the if you look at basically the umbra and penumbra form the totality path and then the partials on the sides, right? Oh no,
yeah.
that is about the right size. Yeah,
Yeah,
actually.
that's right. Yeah, the total
Yeah, yeah,
eclipse
yeah.
normally can be sort of tens of miles wide, where the partial eclipse area can be hundreds, if not thousands, of miles wide.
Thousands of miles.
Yeah,
That's insane.
yeah, you can sort of cover the continent basically
That's pretty crazy.
with various
Levels of
contribution levels
yeah.
of partiality. So the
Yeah.
partiality can go from say 90% eclipse to down to say 5%. That can be 1,000 miles apart.
I guess it makes sense that there's only one spot really where you can see, or there's only I guess it makes sense why the umbra is so much smaller, right? Because you need the moon to be exactly blocking out the sun.
Exactly right.
And
It's a line of sight effect. You're directly in line. Where if you're slightly off angle, you're seeing the partial, but that can be a much larger cone. To be exactly on angle, you end up only seeing the very tiny part that's eclipsed. And
Yep.
if you've ever seen a person walk in front of a car headlights, for instance, or somebody bypass a street lamp, you see that effect, right? You can see some shadowing, but only when they're directly in line do you see the complete sort of blockage.
I think we should take a moment also to appreciate the cosmic coincidence that allows, because what you've described is actually a good example, right? If you've ever seen a person pass in front of in front of a light, they block it out completely. Uh, if you've ever seen something, if you've ever seen a plane in front of the sun, it blocks it out but a little bit. But we are in a very special cosmic time and cosmic coincidence where the moon can block out 99.9% of the sun's light, which is just enough that it gives us a beautiful ring of light effect, but not enough that it just blocks it out totally and we don't get to see any of the corona and all that other stuff.
Yeah, well, that's an interesting one here. I'm really glad you brought that up. We should maybe show, I don't know if we have this on the next image, but we should show what a real solar eclipse looks like.
Yep.
Okay.
From space or from the ground?
Your choice.
Oh, okay. So let's start with the from the ground one,
Yeah,
which
that's
is
an
what
important, right? Good. So this is a NASA image as well. We found this on the NASA website this morning as we were doing some research. Now, this is what your more or less what your eyes can see, actually. Maybe not quite as good a resolution as this is a photograph, and it looks like it may have had some optics as well. But this is the black disk is the basically you're seeing the dark side of the moon. So don't forget it has to be a new moon for it to be an eclipse. So a full eclipse anyway. And so this black circle is you're seeing the dark side of the moon. The sun, of course, is behind it. We'll talk a little bit about some of these edge effects that are around the sort of pinkish white effects. But what's this sort of fluffy Einstein hair looking halo around it?
So that's the sun's corona. It's the upper part of its atmosphere, and it's usually not bright enough. Oh, sorry, it's very bright, but it's usually outshined by the sun itself. And so the best way to see it is if you block out the rest of the sun's light, which is what the moon does here. And this is actually a natural example of, or the natural inspiration for a real scientific instrument called a coronagraph, which is basically not any more complicated than just putting a disk in front of a sun or another star and seeing the dimmer stuff around it. So we use a coronagraph to block out the sunlight on missions like the Parker Solar Probe to right. The Parker had a coronagraph almost for
Well, so
sure.
I don't think the Parker didn't. It was way too close for that because the
Was it? Oh,
Parker
it's a Soho. Was it Soho that had the
Soho had.
Soho? Yeah.
Yeah,
So Soho which is the solar solar helio astrophysics observatory or something like that.
that's right.
It had literally a camera with a disc they'd line up with the sun and it block out the light and you just see the corona. If we want to look at other star systems, we can use a similar thing but with a smaller disc. That disc blocks out the starlight and then you can see like the planets around it if it has any, for systems that are nearby enough. So it's kind of cool that this natural phenomenon inspires a real scientific instrument.
Oh
Also, if
yeah.
you hear any noise in the background, I'm so sorry. That is Pickles.
I'm seeing actually, I'm on the Soho page now. I'm actually seeing if we can find a really good image of yeah, we do. I'm gonna stick this. Let me put this in the chat. If Joseph,
So
you want to.
I mean, here's a
Oh, there you go.
photograph image.
Perfect.
Yeah.
Yeah. So what you're seeing here is this is a Soho image. The sun is actually is represented by the small white disk here. Well, I'm actually Joseph. You may have to do this because I'm using. Well, maybe the viewers on the video can't see it, but it's the very
Yep.
small white disk in the middle. The black
Oh, this
disk
little thing.
around. Yeah, that's the white disk. That's the actual position of the sun. The little
Mhm.
blue disk around it it's actually a piece of, I think it's either ceramic or it may be carbon fiber. It's blocking out the sunlight from the sun. The black shadow you see pointing up toward about 1:30, 2 o'clock on a clock, that is the arm holding the little disk in place on the
Cool.
spacecraft. Right, and then everything else you're seeing is astrophysical in nature. And so it looks like there's a very bright star here on the left, about 9 o'clock position. Yeah, it could be a planet. I
Like
can't tell.
Venus or something.
It could be. It looks about bright enough for Venus, actually. There's a good chance that's Venus,
Mhm.
possibly Jupiter as well, I suppose. All this stuff around it is what what Joseph was referring to as the corona. Now, I've got a really scientific question for us here.
Ah.
Basically, you're seeing some of the solar wind come off as well, by the way. Typically, what do you think the corona emits in? What type of light?
Whoa.
So
Hold
do
on
you
a
know?
second.
Is it microwave? Is it
Okay.
radio? Is it white light? Is it infrared? Is it X-rays, gamma rays? What is
Okay.
it?
I think we can immediately rule out. Um, I think we can. It's got some optical, some component of everything, right? Because it's just so bright. But I think we can immediately rule out optical because this light is way more extended than what we're seeing here. If this white disk is the sun,
Yes.
so I'd say
It's
we'd
still,
rule out
it's
optical.
still, it's still
Sorry.
related, but go on. They're still related, but carry on.
Um, but what I mean is, if all this was in optical, we'd be able to see it extend way out farther. Is what I'm saying in this image.
I'm not sure that's true actually on this image because it's a contrast effect, and
Oh,
the stuff that's producing the light, which I'll explain in a second, is getting thinner and thinner, more and more tenuous as you move away. So if you change the contrast of that, you could potentially see some of this material here scattered around.
okay.
Uh,
I'm gonna say. I'm gonna say. I actually don't know, David. I don't know what the primary component is. Is it
okay,
X-ray?
it is X-rays, right? Absolutely. So
Okay. I
yeah,
only guessed that because I know they do a lot of X-ray imaging of the sun specifically, and they probably wouldn't go out that far unless they were getting something.
oh, that's right. And don't forget, you have to do X-ray imaging from space because Earth's atmosphere thankfully protects us from X-rays and gamma rays and things like that,
Yeah.
which is good. Otherwise, life probably wouldn't have developed here on Earth. So yeah,
No,
the
it would have
typical,
developed. I think it just would have been way cooler.
possibly, who knows? Um, yeah, the typical temperature in the corona can be about 1.2 up to 2 million Kelvin. It's very, very high energy. The energy is dumped in there by the magnetic field of the sun. So all that being true, why are we this is more or less the optical. I can't remember the exact wavelength here, but it's pretty close to the optical, and the previous image from NASA was in the optical. Why are we able to enter this is definitely optical? Why are we able to see the corona if it emits mostly in X-rays?
Uh well, even if it emits mostly in X-rays, that doesn't mean that there's no emission coming from the rest of the spectrum. It might be a black body that it might look like a black body that peaks in X-ray, but there's still other photons that are capable of ionizing gases, which then emit other photons in optical and infrared. And
No, that's a reasonable supposition, but everything is ionized in the corona.
okay, at this stage, yeah. Well, but I mean, yeah, it's my guess. So yeah, so why would it? Is there a specific reason beyond just it does emit at other wavelengths, not just X-ray?
Yeah, no, that's definitely not it. Sorry, yeah, there's definitely
Okay,
another reason.
okay. So what's the reason?
And you can't think of another reason yourself? You're a scientist. I'm putting you on the spot, I realize.
um, so the question is, and it primarily emits in X-rays. Why do we see so much in optical?
Yeah. Where's it coming from?
Uh, and it's not just some. Oh, Pickles is coming here to say hello.
Hi,
Pickles,
Pickles.
do you know the answer to this, buddy? Hello, buddy. Oh my God. Okay, can you inform me and Pickles why
Okay, I'll
you get
inform
so
you
much in
both.
optical?
It's actually scattered light from the sun's surface. And so the
Whoa,
outer
whoa,
atmosphere,
whoa! Scattered off of what?
it's scattered optical light from the surface of the sun. So all this stuff you're seeing here, both on the image, the SOHO image you have up, and the previous NASA image of the eclipse, it's scattered light from the material above the sun in the corona and around it, from the surface of the sun. And so
But
if you
what's
were
it
to look
scattering off of? Like it's scattering
the
off of
the,
gases there,
the
presumably, right?
plasma, yeah, absolutely, it's scattering off the plasma. Yep,
So
and the
isn't
electrons.
that's kind of what I meant though? Like it's you got a lot of radiation that's being scattered by the by
Yeah, but
the Mhm.
it's not emitted. It's not emitted light. It's scattered light.
Oh,
It's
what I meant was like the X-ray is the primary component is X-ray, but it's then being absorbed and re-emitted is what I meant, which is just scattering, right?
yeah, but it's not. No, it's not absorption and re-emission. It's
Oh, it's like
scattered.
Compton scattering.
Well, I don't know if Compton's. Well, I mean, yes, it must be. Any scattering is more or less Compton, right? But
Mhm.
anything, it's surface sunlight that is reflected off the material in the corona. So the solar wind.
Okay.
Yeah, and so what
Huh.
would happen is if you were to look at the corona with a polarimeter in polarimetry, you would see a phase change from the scattering, and that's
Wow.
Yeah, and we see that
That's
in the weather.
incredibly cool.
It's really nice. So that if you go back to the NASA image, our eyes can see all this fluffy stuff, this white halo-ish type stuff, as long as you're using the right safety equipment for your eyes when you're looking at the eclipse, of course. You can see this, and you definitely see it in photographs, because you're seeing scattered light from the surface of the sun.
That's
It's really,
unbelievably
it's
cool.
beautiful. Yeah, it's amazing. Yeah, really nice. So I always like that as a scientific point. Actually, if you throw that image back up for us, it's a beautiful image. It's one of my favorites, actually.
Sorry.
It's not quite the diamond ring. So we talked about this earlier. I can see something on here called Bailey's beads. What are Bailey's beads?
Are these Bailey's beads in this
Yep.
image?
Yep, there's one. There's a whole bunch here on the top at the 2 o'clock position. A couple low
Whoa.
down. Well, these also look like there's some prominences going on. That
Yeah, I think they're prominences. I think the
yeah.
Bailey's beads look a bit different.
Yeah,
Like these look
well,
like prominences coming out of the sun.
yeah, they do. You're quite right, actually. The more closer I look, they're Bailey
Let me.
bead
I can try to
like.
pull up an image.
Why? Bailey's beads, yeah.
Okay.
Okay.
Here we go. Yeah, I think
Ah,
these are the prominences that we're seeing. These
those
are
are
the
prominences,
beads.
but these are the beads, right? So,
Yeah.
okay, what are these Bailey's beads?
So the moon is not a perfectly spherical cutout like it is in the coronagraph, and so when it passes in front of the sun, some of the sunlight leaks through the mountains and craters and stuff on the moon,
That's
which forms
exactly
these
it.
little beads, which is like the coolest thing I've ever seen in my life.
Oh, so super cool. I love it, love it, love it. Yep, it's one of my
It's
favorite
literally like
parts.
you're watching a sunrise on the moon, is what it is.
Yeah, absolutely. Yep, yep. You know what? When I lived in Chile, and in fact, when I used to visit the observatory a lot, even before I lived there, I would often at the end of the observing night, you typically have to stop. If it's photometry, you have to stop when the sun's about 10 degrees below the horizon. Depending on what type of spectroscopy you're doing, you can get away with a little bit more. But generally, you'll finish before sunrise. And I would go outside and I'd see the sun rise above the Andes in the east. And you would already see, even if you couldn't directly see the sun itself, you would see the shafts of light being coming through the atmosphere from being scattered basically by the Andes mountains, the peaks in the mountains. And
That's
because light,
so
of course,
cool.
light travels in straight lines, so you see these very sort of light and dark, very straight shafts of light coming across the sky in the early morning. It's just beautiful. It was sort of like an earthbound Bailey's beads. It was beautiful.
That's spectacular.
Yeah, it's gorgeous.
That's
Very
got to
nice.
be one of the best bits about astronomy is we get these crazy locations with
Yeah,
unbelievable views just by construction.
just very lucky. Yeah. Well, yeah. Well, there's more than luck. It's so we build the telescope in these exact places.
Luck ain't got nothing to do with it.
No, no, exactly right. So yeah,
But
this
this
is
image from Jason Major, I think shows the Bailey's beads. Like you can see it in the ripples of these, but I think these purple things are prominences,
yeah. I think you're right. It does look like a prominence. You're quite right. And the
and I
prominence
think that's what we
really,
were seeing here.
yeah, yeah, you're right. There's definitely some Bailey's beads effect, I think.
There is, but I think the image is not high resolution enough for us to see him here. Like a
Yeah, I think you're right. But yeah, the sort of reddish ones above the surface, the apparent surface of the moon and the sun, those are prominences, which are these sort of ejector or explosions that come up from the surface of the sun due to the magnetic field energetics. So, yeah.
which is super cool. If you were closer to the sun, they'd look more like this,
Oh yeah, look at that. I
which is
love that.
just
Yeah,
spectacular.
yeah, that was a monster one, that one. Yep, that's a
I
beautiful one.
remember.
Yeah.
Um,
This looks like an
oh,
H alpha light, actually. This is just
oh yeah,
beautiful.
these are absolutely some sort of extremely narrow wavelength band,
Yeah, narrowband filter.
not optical. But I mean, there are people though that like there are people who do amateur H alpha solar. It's uh there are people like amateur astronomers who do it. So guys, like this is not something that's like completely just for professional equipment only. Like this is you can make these amateur images. And I say amateur as in they're not made using space telescopes.
Yeah.
But you can make these
Oh,
beautiful
look at that.
images that amateur astronomers have done where you can see the prominences and the magnetic field effects. So like this is the sun is one of the most interesting objects in the sky, and I feel like it's severely underrated as an astrophotography target. But it is hard to like get these level
Yeah,
images.
it really is. Oh,
But
look
if
at
you have
that.
the that's just spectacular. If
Oh,
you have
yeah.
the equipment though, if you have the equipment, it's I mean the sun's up basically every day, which I realize is something I say as a spoiled person living here in Santa Barbara. But if you're not in, you know, Nottinghamshire, UK, or whatever it is. Uh,
By Nottinghamshire, do you mean Nottinghamshire?
not Nottingham Shore,
Not
Nottinghamshire,
Nottinghamshire. Yes, it's not. It's
Nottingham
not.
Shore.
It's not Lord of the Rings in Great Britain. It's not like the Shire.
The
Shire.
Shire. If you're not in Mordor, you get the sun every day.
That's right.
um, but it is a spectacular, spectacular images.
Yeah, very,
Um,
very nice.
so okay, so take us through the stages of a solar eclipse. We've got this lovely image here from MrEclipse.com, which is this nice
Yeah.
composite of like what's going on.
Oh,
So what do you
beautiful.
see from beginning to end?
So it's a mirror. It's obviously a mirror. So what happens on the left is happening on the right. So let's just start on the left. So the very left
Now, is
image.
this a big space mirror? Like, could you see your reflection in it? Sorry, I'm
Oh,
kidding. I'm just fucking around.
they just get worse. Just get worse. Yeah, that's pretty bad. Okay, so yeah, if we start here in the 9 o'clock position, right off on the left, this is just after first contact, and first contact, as the name implies, is when the limb or the apparent shadow of the moon just touches the limb or the surface. Not they're projected, of course, they're not in the same place, but the apparent surface of the sun. So it's sort of like that. But
Is
then
there a
we get
reason
a
we call
bit.
them limbs and not like edges?
That's what it's called. They're called limbs. I'm not really sure why,
I'd like to
actually.
meet the guy that came up with that.
I don't
I
know. I don't know why he or she chose that.
I just can't think of it anything less limb-like than a circle.
I don't know. Maybe it's Rush
Sorry.
Limbaugh.
Yeah. So edge of limb, moon limb
Yeah. So
gently
this one on the
caresses the
left,
sun limb.
yes, it's basically sort of, you can already see it's taken this sort of almost like this mini Pac-Man nibble out the sun. Yeah, right on the left.
Yep.
So this looks as though it's cool, maybe 1/8 or maybe 1/10 of the way in. And so this
Mhm.
dark little sliver here, you're really looking at the front surface of the moon, covering right in the background, the surface of the sun. So this is
Yep.
right near the start of the eclipse. Now
Okay.
here on the next one over, yes, the where your cursor is, the next one over, this is really now the eclipse has started in earnest, and it's really now taken a good sort of 1/3 sort of bite out of the sun. And that sort of black crescent you're seeing there is the front side of the moon, the new moon, really doing a really good job in covering the sun in the background. Now, the next one over, it looks like you're just over maybe halfway, maybe a little bit more, maybe 60%.
I think
The
a bit more.
eclipse,
Yeah.
yeah, maybe a bit more. The eclipse is really moving toward totality, and you're seeing the surface of the moon starting to cover the disk of the sun really quite substantially.
We call this
And
the DreamWorks moon phase.
yeah, it kind of is like the DreamWorks moon phase. This line, by the way, it's sort of related to the term Terminator. Now, the Terminator, when you see the moon, say like a half moon, three-quarter moon, that line between light and dark is it's called the Terminator. So this line here is sort of cutting the sun like
Is it
into
because Arnold Schwarzenegger's character kind of walked the line between,
light and
you
dark.
know, light and dark?
Yeah, it's actually nothing to do with that, but thanks for asking. I think it's much more to do with Euclidean geometry, I suspect, but yeah. So this sort of Terminator-like line is really you're really seeing the very limb of the moon covering the surface of the sun in
Yeah.
apparent projection. And then this one here is almost totality. You're seeing this very, very thin crescent, and you can see that the moon is just about to cover entirely the sun. So you've got this very thin sliver of light. Now, at this point, if you're outside and it's not cloudy, it'll be quite dark. And so what happens is as you go from left to right here, it's getting darker. One thing I've noticed, and it's ridiculously obvious, is it gets colder. It can
Yeah, the
drop.
temperature drops.
It does. It's phenomenal how quickly the covered sun starts dropping in temperature. And so yes,
And the
this is
birds go crazy and
they do in totality. The birds go quiet. They stop moving. It's amazing. They think it's nighttime effectively.
so cool.
It's very eerie. So of course, by the time you get to the middle here, this is a total eclipse. It's not an annular eclipse. You can't see a ring of light just around it like a wedding band. It's not a partial. This would be a partial, maybe if you looked on the left here or the right. That was what a partial eclipse looks like, and so it is
Well, I
being
think
part.
they all are. You mean everything on the left and right?
Yeah, well, that's right. So you're moving through. Well, I meant a partial eclipse, as in the eclipse wouldn't be total at all. This is what you might expect to see in a partial eclipse.
Oh, I see. Gotcha.
But then as you move towards full totality, you can see now the disk of the moon covers entirely the disk of the sun. And so the geometry, as you mentioned right near the start of the video, is just perfect, that the relative sizes of the moon and the sun exactly match the relative distances between us and the moon and the sun. It's a beautiful cosmic coincidence.
What a coincidence. So because it's like it's a the moon is like X times smaller than the sun, but it's also X times closer to us.
Yeah, just perfect.
So it's just so cool.
Yeah, well, the natural consequence, of course, of as and we mentioned this in one of our earlier videos, is that as the moon slowly moves farther and farther away from the Earth due to gravitational interchange with the Earth's oceans, essentially, it's leaking gravitational energy. Total eclipses in the future, a long way in the future, talking hundreds of thousands, if not millions of years, total eclipses will no longer be possible.
That's
They'll be
insane. So we're in
yeah.
a very lucky time period.
Oh yeah, for humanity, it's phenomenal. It's just amazing.
I,
So
I like the fact that if you you can't see the prominences and like the corona at any other stage except when there's totality, because even when the sun is like 1% visible, it's still bright enough so that you can't really see the corona.
yeah, that's right. That's
And
right.
that should be a warning. Don't look until it's completely covered.
That's right. That's right.
And even during an annular eclipse, don't look, because even though the sun might be 99% covered, it's 1,000 times brighter than it needs to be to destroy your eyes.
Oh, it's very, very dangerous. Yeah, and then especially through, say, binoculars or a telescope. If you have any optics that can improve the magnification, you should never be looking directly at the.
Yes, binoculars will give you a great view of your impending blindness.
No, that's right. Yep, yep, yep. And so, you've seen this before where former President Trump looked up at the eclipse without
Oh my
protection.
God.
Yeah, it's
And
like, don't
pointed.
do that. Yeah, really bad idea. This is coming from a scientist, to a pair of scientists.
Yes, that
Please
is
do
a
not look at the eclipse without protection.
terrible, terrible idea to do that.
So speaking
But yeah, it is
so, okay.
in totality though, it is safe. In totality, it is safe.
Yes, yeah, very,
Yeah.
very briefly it is, yeah. So if you, in terms of actually, let's talk about safety a wee bit. In terms of getting these very special glasses that allow you to see the shadow of the moon projected onto the sun's disk, you can typically get them for free from your local library. From if you live in a place where there's a museum, they will probably be freely available. And there is maybe I can find it and stick it in the we can stick it up, or you can do a search, Joseph. You can actually get them from NASA, but you have to do it. You have to order them now because they take a little bit of time to come, and they're free, of course. But yeah, typically your local library will have them. Any science institute around, like a science museum, if you happen to live near a big enough city. And you could, of course, if I would try and avoid paying for them if you can help it. You can get them on places like Amazon and
And they are super cheap if you want to. If you have like Amazon, it's like $10 for like 20 of them. Like they're very,
yeah,
very cheap.
yeah, they are, but they're worth it to protect your eyes. So we
Oh
can't
yeah,
emphasize this enough. So
and yeah, I mean you can wait until totality, but like it's really fun to watch the eclipse through the eclipse glasses as it's happening. Like
as it's happening,
it's
oh, it's
quite
amazing.
alarming to
Yeah,
see the sun getting eaten.
yeah, it sort of appears to be eating it. Yeah, it's incredible. It's it's one other thing to remember is, and I've done this with myself with the children back in 2017, is just be careful when you're going out to these places, because people often stop on the side of roads and they'll get out to
Mm.
take pictures and look at. Just be really careful with your children, cars driving past. That's really important.
Yeah, get there well before, get comfy,
Yeah,
and be
get
prepared
comfy,
to
get
not
hot.
be able to leave for a
That's right.
while after, because it's unlikely you'll be the only person there.
That's right. So speaking of which, why
Yep.
don't we throw up the map so our
Yep.
listeners can see where it's going to be?
Okay.
This
Now
is
I'm gonna pull up the map on the NASA page so we get the best resolution. But
that's
if you're wondering where and when to see it, it's April 8th, and the when is going to depend exactly on where you are. But
yeah.
basically, it's going to cut this big path right across the continental United States.
Yeah, that's true. So, okay, so that's good that you mentioned it's the 8th of April this year. What you're looking at, if you're not entirely sure, is you're looking at a sort of map of North America. You have Central America, obviously Mexico down here, where the eclipse map sort of starts. The light grey tan area is the contiguous United States, and then obviously the area at the top is Canada. And this sort of black swathe, this black arc, this black almost like rainbow looking thing going through the map, that is the path of totality. Whereas in if you were there, you would be able to see a total solar eclipse as the shadow of the moon projects across the continental US and northern North America.
Now, this little yellow ring is the shadow of the moon being animated as it follows the path in
Yeah.
Pacific Daylight Time. And as it passes over the cities, that's when you'll get totality.
Yeah, so you can maybe zoom in a tiny bit there, Joseph. You'll be able to see. Yeah, so this goes. So it's gone through Dallas there. Looks like it's going through Arkansas now for our North America, for our US based friends.
And this is at
And
60 times speed. So
yeah,
it'll
yeah.
the full, if you're in totality, the full eclipse will last about 7 minutes.
That's if you have a perfect eclipse. If everything lines up perfectly. This
Yes,
year,
if you're exactly, yeah.
this April, the maximum time I think is going to be 4 minutes down toward Dallas, Texas, and then by the time it gets up into Maine, I think it's about 2.5 minutes.
Okay, gotcha.
Uh,
Yeah, so yeah, Dallas, Texas is gonna be total, yeah, 4 minutes.
4 minutes. That's right.
Yeah.
Okay.
But
So yeah,
the partial eclipse will be several hours.
yeah, that's right. It's about 2.5 hours for the. That's right. But the
Yeah.
totality is really short, and as Joseph mentioned, the maximum totality you could ever have is about 7.5 minutes.
Yeah.
We're not getting that this year.
We're
So
not so
that's really,
lucky.
we're not so lucky. So Joseph out on the West Coast, if he stays there, he's not going to be able to see it, but he will see partial. You might be at the sort of 30-40% level out here, Joseph, I suspect.
We had the annular eclipse a while ago. We had a
Oh
partial
yeah.
out here. That was like 80%. It was spectacular.
Oh, beautiful.
It was
Just gorgeous.
incredibly eerie. Even just a partial eclipse, if you can go see
Yeah.
it, like the light looks different. Like it's the middle of the day, and like it could be sunny out, but there's no clouds, but the light is dim. Like it's
It
very
is. Yeah.
cloudy.
It,
It's
it does. It feels.
so it's very bizarre. It kind of gives me like a sense of like what life would be like if we were around a dimmer star.
Yeah, absolutely. It would be a different life form, that's for sure.
And we can as the moon passes in front of the sun, we can measure the dip in brightness and use it to estimate the moon's period and orbit.
Yeah, absolutely. Yeah,
So
that's how we can measure
just a little
something.
Kepler joke there. I went to a talk recently by one of the Kepler one of the Kepler folks, and so I've got a lot of Kepler jokes off the top of my head. But
Nice. Well, it's funny you say
yeah,
that, though, when we look at extrasolar planets, many of them are found by the transit method. We can see the dip in
yeah,
light as the
that's what I
planet.
mean.
Well, it turns out what you end up measuring is the ratio of the radii of the planet compared to the star. And
Right,
so that's really how we need to know the fundamental radii of stars, is so that we understand we can measure the radius of the planets orbiting them. And
right.
there is
And
a
but the
couple of
problem
theories.
is the moon is orbiting the Earth, not the sun, and so
That's
we
right.
can't use it to like construct the properties of the solar orbit.
Well, but if you know the relative distances and you know the radius of the moon, yeah, you can. Yeah.
You can do it to get the orbit around the Earth, but the moon doesn't orbit the sun effectively,
No,
or at
no,
least it does with the Earth. Yeah.
no. It's very
Um.
complicated. Yeah.
Yeah. But
Uh,
yeah. So this is the path. If
yeah,
you're in this, you'll want to get in this path to see the total solar eclipse.
yeah, that's right. So if you the solar eclipse or the projection of the shadow is this yellow oblate spheroid moving uh, well, the spheroid is three-dimensional, but
Oh,
oval moving on
we
here.
have a couple
But if
we
you
have a
zoom
couple
in,
settings.
oh
Sorry, we
yeah,
can turn on. So this is the umbra, but this is
oh
the
yeah, do the
penumbra.
penumbra.
Wow,
Oh,
that's
yep, there you
so
go.
big.
Thousands of miles. Yep.
I think the Mercator projection is making it look bigger than it
Yeah,
is too.
that's true. Yeah, I agree.
But
But
that's
if you,
spectacularly
yep,
large.
yep, it's huge. Yep.
Wow.
Oh, so it changes.
Uh,
It changes shape depending
Yep.
on where you look.
Here's a percent coverage. So you're right. I will see about you nailed that. We're gonna bet. Oh, we'll get about 50% coverage actually.
Yeah, 40, 50. Yeah,
Okay.
there you go. Yeah.
Here's a length of totality. Yep, four
Oh,
minutes at
yeah,
the
4 minutes.
best.
Nice. So
And
if
then
you,
yeah,
oh, sorry, if you zoom into to Maine and try and get the
yeah,
map to have the path there,
there we go.
because that I think I'm going to go to Maine. Because I'm just north of Boston,
Yeah.
and I was going to go to Burlington over there by,
Yeah.
Lake Champlain there on the Vermont New York state border. but I think I'm going to go up to maybe, I can't read it, maybe Malinute. Is that the one that say? I can't read it. Mini rocket?
Millinocket. I'm trying
Millinocket.
to zoom in, but it doesn't make it bigger. Yeah, Millinocket.
Oh yeah. So anyway, just north of Bangor.
Yeah.
Yeah, I think I'm going to go and go up there because I think there'll also be less people up there, so there'll be less sort of
Yeah.
traffic on the road, and
And
it's
the
about
light pollution will be really low too. I know it doesn't, but I know you're wondering. People might be wondering why does light pollution matter in a solar eclipse? But when the sun goes dark, if the light pollution is low, you can see the stars and like
correct.
even the Milky Way, which is
Yep.
crazy.
Yeah, no, it's madness. Yeah, you can see stars. That's right when the sun's completely eclipsed. Yeah, it's very exciting. Um,
I mean, famously, the Eddington experiment was the first test of general relativity. And what they did was they measured stars in the sky and then measured their positions after a total solar eclipse. And the positions had shifted slightly due to the light being bent around the sun. And the shift was exactly as predicted by general relativity. And they were able to do this experiment back in the early 1900s. So like
yeah,
back when everything was in black and white. So
yeah, life is black and white. So, well, I thought the Eddington wasn't the Eddington experiment 1919 with the eclipse of Venus, or am I thinking of something else?
No, Venus. It was a total solar eclipse that shifted, and the starlight, the stars near the sun,
Oh,
changed
that's
the
right. That's right.
yeah
And Einstein's general relativity predicted the
the
deflection.
the the deflection exactly. Yeah,
Yeah, that's right. But it was tiny. It was
yeah.
like half a degree or something.
It's unbelievably small. Which, as
Yeah.
much as I was joking about the black and white thing, like it is kind of amazing that they were able to measure deviations that small.
For this eclipse coming up in just 4 weeks' time, obviously I'm very lucky that I only have to drive a couple of hours. I'm going to get to see it.
Yep.
It is
I also only have to drive a couple hours after a 8 hour plane flight.
after an 8 hour plane flight. You'll be fine. So, well, if you do make it to this part of the country, Joseph, I would love for you to for us to do the eclipse together, and
That would be fun.
that would be a lot of fun. A lot of silliness, but a lot of fun.
Oh yeah.
Uh,
Let us know if you guys would like an Astraveo video about the eclipse in the comments.
Yeah, actually, that's one thing we could do. And in fact, I will take some footage when I go up to Maine. But it's one of these great astronomical events that makes you feel the sort of smallness of humanity. It really is incredible because, as you said, it goes dark, it gets cold, the birds get a bit agitated, but then they settle down, and then it becomes very quiet. It's very eerie, actually.
I can understand why people in the past may have looked to these events as like symbols of the
Oh yeah,
divine. Even
absolutely.
now, it's kind of they're kind of frightening to me. Like a benevolent god, like a this awesome event that we're just lucky isn't harmful because how the
Yes.
heck would we stop it? Like
Yeah,
you
well, that's
couldn't.
probably thousands of years ago. That's probably what they thought. They probably thought it was the action of a god, and had they done something wrong? Did God, did their deity make the earth cold for 5 minutes, or why did he make it dark? It was incredible.
It's what a remarkable event. So yeah, if you guys can go out and see it, you definitely should.
Yeah.
Um, good luck.
Well, this wraps up another presentation for Astraveo, where we go from geek to chic by sharing our passion and excitement for all things scientific, especially astronomy and in the mysteries of the universe. If you enjoyed this video, please hit the like button, and in the comments below, please leave us your suggestions for future presentations. We'll get right on it. And don't forget, you can join us on our journey by subscribing and hitting that bell. He's Joseph, and I'm David, and together we're Astraveo. Thanks for watching.